All right, so y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answer. So for the factoring, you're going to do remove, replace, reduce. So remove the 3 by multiplying it by the 10, and you'll have x squared plus 17x plus 30. And then you're going to factor. So you're going to have 3x and 3x, and you're going to want to use 15 and 2. So the first one will divide by 3, you'll have x plus 5, and then the second one will stay 3x plus 2. And so that would be your answer. For the math knowledge question, we want to know what gives the expression y in terms of x and n. So we're basically just going to solve for y. So m minus n, and then divide by 5. And that is A. So that would be your answer for that one. So we are looking at lesson 41 today. We're looking at graphs of rational functions part 3, and then we're going to look at repeated factors. So hopefully you'll understand more about rational function graphs and repeated factors after this lesson. Vertical asymptotes and x-intercepts, your zeros of your rational functions, are not affected by irreducible quadratic factors. So x squared plus any number would be an irreducible quadratic factor. We already talked about that. I told you whenever you see these, you just mark them out. So we want to graph this one. So do you see any irreducible factors that we would want to mark out? Hopefully you see this one, x squared plus 2. So we ignore it. We don't use it. And then we're going to look for where our x factors are going to equal 0. So that would be at x equals 1. For the denominator, it would be -3, 2, 3, and -2. So hopefully you're remembering a little bit about this. And we're going to graph, and we need to graph so that we have all of these numbers. So I'm going to do -4, -3, -2, -1, 0, 1, 2, 3, and 4. So that's my x-axis. So I put a dot at 1 because that's the 0 from the numerator. And then I put asymptotes for the ones that occurred in the denominator. So -3, 2, 3, and -2. Those are supposed to be vertical lines, not curves. Alrighty. So now we pick a number to the right of our rightmost 0 or asymptote. So that would be 4. And you want to see if it's positive or negative. Positive, 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 positive. But there's a negative out front. So all of these were positive, so it's a negative. So we're going to start right below the x-axis. And then you're going to approach your asymptote. And then you're going to jump at your asymptotes, and since there's not a 0, we're just going to have to go back to that asymptote. And then we're going to jump at the asymptote, go through this 0, approach that asymptote. We're going to come down here and make a little U because we can't we can't cross the x-axis. And then we're going to come and jump across and then just approach the x-axis. So that's the graph of that rational function. That should mostly be review from much earlier in the year. So now we're going to look at repeated factors. That's more of the new part. So if you have a linear factor that's repeated an even number of times in your numerator or denominator, then the graph is changed. If it's an odd number of times, so if it's to the 3rd or to the 5th or to the 7th, it's not going to change the look of the graph. So it's only if it's squared to the 4th, to the 6th, etc. So the graph of it is no longer going to cross the x-axis if it's raised to an even power. It's going to touch it and bounce away. Okay? So if it's not going to cross it at that 0. It's going to touch and bounce away. And if it is an asymptote, instead of jumping, well, it jumps once, but then it has to jump twice because it's repeated. So it's really just going to make a volcano. So that's what's happening if it's going to be raised to an even power. either going to bounce or it's going to make a volcano. All right, so let's graph these. So we have no zeros in our numerator, so we don't have any dots that we need to put, but we have an asymptote at 3 from our denominator. And so I'm just going to graph 3 and the asymptote. I'm not going to graph the rest of the number line. Okay, and then we need to pick a number to the right of 3, so pick 4. If you plug 4 into this, it's going to be positive, so it's going to start above the x-axis, and then it's going to approach the asymptote. Okay, and then since it's a squared, we jump, and then we have to jump back. It makes a volcano, and so it looks like that. So that's the graph of A. For B, again, we don't have any zeros in our numerator, so we don't have any dots. So this is 3, and so you're going to have an asymptote from it. And then if you pick 4, this whole thing is going to actually be negative because there's a negative out front. So that means we're going to start below the x-axis, and then you're going to approach your asymptote, and you can think of it as jumping twice or just volcanoing because it's a square. And so that would be the graph of that. So that's how the squares affect the graphs. So let's look at volcano. That's what I was just telling you. Whenever you have a volcano, that means that it was raised to an even power. And they call it volcano. You can think of it however you want. But that just means that your denominator had a factor raised to an even power. So we want to graph this one. So first off, you want to get rid of any of your irreducible factors. So you have to look carefully because it's not just if you see a squared, it's only if you see an x squared. So the only one that's an x squared is this one right here, x squared plus 1. So mark it out and ignore it. So now you're going to look at your numerator. You have a 0 at 1, and in your denominator you have a 0 at -2, 3, and 6. So we're going to go graph. This is our x-axis. We're going to start at -3. Okay. So we're going to put a dot at 1. And then we're going to put an asymptote at -3. I mean at -2, sorry. At 3. And at 6. And so now you need to plug in a number to the right of 6. So pick 7. And you just need to check and see, is it positive or negative, to know whether you start above or below the x-axis. So this irreducible factor, again, that's not going to change the graph. So you don't need to worry about plugging it in there. But if you plug it in here, that one's going to be positive, that one's positive, that one's positive, and that one is positive. So we're going to start right above the x-axis, and then we're going to approach the asymptote. Now at 6, x minus 6 was squared, so that means that we have to volcano at that one. And we can't cross the x-axis because there's not a dot, so we approach the asymptote again. At 3, it was also squared, so again we're going to volcano. But we do have a dot here. Now the question is, are we going to go through it or are we going to bounce away? The 1 is squared, so we're not going to go through it, we're going to touch it and bounce away. And then approach that asymptote. And then at -2, this one is not squared, so we just jump like normal. And then we approach the asymptote, the x-axis. So that is how you would do repeated factors. So you have to be really careful that you're looking at the correct ones for which ones are squared and which ones aren't. But that's basically all for the graphs of rational functions. So your homework is 1 through 25. Make sure you do those tonight so we can go over any questions that you have tomorrow.